adding and subtracting algebraic fractions. If we think back to numerical fractions, if we've got 2 over 3 plus 4 over 7, the way we do that is we find the common denominator between 3 and 7. That's going to be 21. To get from 3 to 21, we've multiplied by 7. And from 7 to 21, we multiply by 3. And we need to repeat that on the numerator. So if we multiply 2 by 7, we get 14. And if we multiply 4 by 3, we get 12. Then we need to add the numerators. 14 and 12 is 26 over 21. And that would be 1 and 5 21sts. Now to add or subtract algebraic fractions, we do exactly the same, where we get a common denominator. And we always look for the lowest common multiple of the denominators to make the question as easy as possible. But with most of our algebraic fractions, what we'll be looking at is multiplying both denominators together to find the lowest common multiple. So write the following as a single fraction. Part A, x over 5 plus x over 7. So what we need to do is find the common denominator. So the common denominator between 5 and 7 is 35. To get from 5 to 35, we've multiplied by 7. So we need to do the same on the top. And that's going to turn into 7x over 35. And to get from 7 to 35, we've multiplied by 5. So doing the same in the numerator, and we get 5x. Then we need to add the numerators together. So 7x plus 5x is 12x over 35. Example B. Our common denominator here, we could go to 50, but I'd say the lowest common denominator is 10. To get from 5 to 10, we multiply by 2. So multiply the top by 2 and you get 4x. And the 3x is going to be unchanged. Then we subtract the numerators. 4x take away 3x is 1x. So we've got x over 10. Example C, we've got thirds and sixths. Again, we can multiply those together to get a common denominator of 18, but I'd say 6 is the lowest common denominator. So the first fraction has a denominator of 3. We need to get it up to 6, so we multiply by 2. So we need to multiply the top by 2, and to do that we write 2 brackets x plus 1. And then we're taking away x plus 2 over 6. Expand out the brackets on the first, so we multiply the 2 into the bracket into both terms, and we get 2 times x is 2x, 2 times 1 is 2, and we're taking away x plus 2 over 6. Now we need to subtract the numerators. Now with the thing we need to be really careful about here is that we're subtracting the x and we're subtracting the plus 2. So that means we're going to have to consider our rules for negatives. So we're looking at 2x, take away x, and that's going to give us 1x. And then we're also going to be thinking that it's plus 2, take away plus 2 is the same as 2, take away 2, so that's going to be 0. So we're left with just x over 6. Example D, we've got thirds and halves we're dealing with, so the common denominator there is going to be sixths. To get from 3 to 6, we multiply by 2, so we need to multiply the top by 2. If we multiply the top by 2, what we're going to get is actually 4 brackets x plus 1. So we'll multiply the 2 by 2 and we'll get 4. And then we need to multiply 2 by 3 to get 6, so we multiply the numerator by 3, and we get 3 brackets x minus 3. So if we expand out the brackets, the first fraction becomes 4x plus 4 over 6. Then we're taking away 3x minus 9 over 6. So again, this is now going to be something that we need to think about. We're taking away the second fraction, so we're taking away the 3x. We're also taking away minus 9, so we need to be really careful with our rules for subtracting negatives. So now what we're looking at is 4x take away 3x, which is single x, And then we've got positive 4, take away minus 9, taking away a minus becomes a plus. So we've 4 plus 9, which is plus 13 over 6. Example E, we've got 3 fractions that are being added together, and the denominators are 3, 4, and 2. The lowest common multiple between 3, 4, and 2 is 12, so we need to change these fractions all into twelfths. So the first fraction, to get from 3 to 12, we need to multiply by 4. So if we multiply 1 by 4, we get 4. Second fraction is 3 brackets x minus 1. If we multiply that by 3, it's going to change it to 9 brackets x minus 1. And we need to multiply the third fraction. To get from 2 to 12, we multiply by 6. So we need to multiply x plus 2 by 6. The way we write that is 6 brackets x plus 2. We can expand out the two sets of brackets, so we're going to have 4 over 12 plus 9x minus 9 over 12. So remember, we're multiplying the 9 into the x and into the minus 1. And likewise, we multiply the 6 on the x and the 6 on the 2 to get plus 6x plus 12 all over 12. Then we need to collect like terms. So number-wise, we've got 4 plus minus 9 plus 12. So 4 plus minus 9 is 4 take away 9, which is negative 5. And negative 5 plus 12 is 7. Then we've got letters. We need to look at collecting the letters together. We've got 9x plus 6x. So 9 plus 6 is 15. So we've got then plus 15x, and that's over 12. Example F, we've got denominators of x and 2x. And the lowest common multiple there, the lowest common denominator, is actually 2x. So they each share a factor of x, so we need to get up to 2x. The first fraction, to get from x to 2x, we need to multiply by 2. So if we do the same on the top, we get 4. And the second fraction, we don't need to do anything to that. So then adding the numerators, we get 7 over 2x. Now that looks like a top-heavy fraction because 7 is bigger than 2. But because we don't know the value of x, we don't change that into a mixed number. We just leave it as 7 over 2x. Example G, we get x over x plus 1, take away 2 over x. So this is a case where the common denominator is going to be found by multiplying the two together. So x on x plus 1. So the denominator in the second fraction is also going to be x upon x plus 1. To get from x plus 1 to x times x plus 1, we've multiplied by x. So if we've done that in the denominator, we need to do it in the numerator as well. So we multiply x by x, and we get x squared. The second fraction, to get from x to x upon x plus 1, we've multiplied by x plus 1. If we do that in the denominator, we need to do it in the numerator. So we multiply 2 by x plus 1, and we get 2 upon x plus 1. We'll expand the bracket on the second one, so the first fraction is going to remain the same. The second one, multiplying the 2 into the bracket, and we get 2x plus 2 over x upon x plus 1. Then we need to try and collect like terms in the subtraction. So we've got x squared take away, well there's no other x squareds there, so that numerator is going to be x squared. Then we don't have any x's on the first fraction, but we're taking away a 2x, so that's going to be minus 2x. And then number-wise, on the first fraction, we don't have any number, but we're taking away a plus 2. Remember, it's not just a plus 2, we're taking away this plus 2, and a minus and a plus make a minus, so it's going to be minus 2. And the denominator is x brackets x plus 1. If we could, we should always try and factorize this numerator because we might be able to simplify at some stage. So the sum is minus 2 and the product is also minus 2, but there aren't any numbers that multiply to give minus 2 and add to give minus 2. So x squared minus 2x minus 2 can't be factorised. So this is its simplest form. Example H then, we've got 1 over x plus 1 over 1 minus x minus 1 over 1 plus x. The common denominator here is going to be the three terms being multiplied together. So x upon 1 minus x, 1 plus x, plus x upon 1 minus x, 1 plus x, minus x upon 1 minus x, and 1 plus x. So there's our three fractions with a common denominator. So the first fraction then, we've got an x and we've got x upon 1 minus x, 1 plus x. We've multiplied by the two brackets. So because we've done that on the denominator, we have to do it in the numerator. And we're going to get 1 upon 1 minus x and 1 plus x. The second fraction, it already has the 1 minus x, so it's got the middle term. So we need to multiply it by the other two. And we've done that in the denominator, so we need to do that in the numerator as well. So that's going to be 1x upon 1 plus x. And then the last one, it's already got the 1 plus x, so we've multiplied it by x upon 1 minus x. So we need to do the same in the numerator. And that's going to be 1x upon 1 minus x. If we expand out the brackets, so if we think about the first thing, we're multiplying the two brackets by 1, which means they're going to stay the same. But we can use FOIL to expand the 1 minus x and the 1 plus x. So we've got the first, the outer, the inner, and the last. And that's going to work out to be 1 minus x plus x minus x squared over x upon 1 minus x, 1 plus x. The next one again, you've got 1 multiplied by x multiplied by 1 plus x. So multiplied by 1 isn't going to change it. So we multiply into the bracket and we get x plus x squared over x upon 1 minus x and 1 plus x. And then we're taking away, again, 1x is just x. X multiply into the bracket of 1 minus x is going to give us x minus x squared over x upon 1 minus x, 1 plus x. The first fraction, we could simplify that. So 1 minus x plus x. The minus x and the plus x, that's really 0x, they cancel out. So you're just left with 1 minus x squared there. So now what we have is need to try and add and subtract these. So if we go through it term by term, the first one is a 1, and there's no other numbers there, so it's going to be a 1. Then we've got a minus x squared. So if we look through for all the x squared terms, so we get this minus x squared, and then a plus x squared, and then a minus x squared. So the minus x squared plus a plus is just plus x squared. So minus x squared plus x squared, well, they cancel. And then we've got nothing really. And then nothing, take away minus x squared. So that's going to be a plus. So we're left with a plus x squared. The next term we come to is a plus x. And we've got a minus x after that in the next fraction. So we've got x, take away an x is nothing. So then what we're left with is that the numerators all simplify to 1 plus x squared, and the denominator remains the same as x upon 1 minus x and 1 plus x. Again, we should try and factorize the numerator, but this isn't a difference of two squares because it's a plus. So it can't be factorized, so we've got to leave it as 1 plus x squared over x upon 1 minus x, 1 plus x.